Welcome dear student and Jai Swaminarayan. Today in this video we will see the textbook solve example of chapter number 12 sound. So dear student, let us start with the first solve example of the textbook of chapter number 12, example number 12.1. A sound wave has a frequency of 2 kilohertz. A sound wave has a frequency of 2 kilohertz and wavelength 35 centimeter. How long will it take to travel a distance of the 1.5 kilometer, right? So here given that the frequency of the sound wave is 2 kilohertz, right? So here the frequency of the sound wave, we take a frequency of sound wave nu is equal to 2 kilohertz. Dear student, we know that 1 kilohertz, that is the 1000 hertz. Here 2 kilohertz, that means the 2000 hertz. So frequency of sound wave is given to you 2000 hertz. And the wavelength of the sound wave, wavelength is denoted by Greek letter lambda. The wavelength is given to you 35 centimeter. So we need to convert this 35 centimeter into meter. 1 meter is equal to 100 centimeter, right? So we can say that 35 centimeter, that is the 35 divided by 100, 0.35 meter. So understand, so given the data is the frequency of sound wave is 2 kilohertz, that is the 2000 hertz, and wavelength of the sound wave lambda is equal to 35 centimeter, that is a 0.35 meter. Now what we want to find? We want to find how long will it take to travel a distance of a 1.5 kilometer, right? So how much time taken by a sound wave to travel a distance of a 1.5 kilometer? So here first we calculate the speed of the sound wave. The speed of the sound wave V is equal to wavelength multiplied by frequency. We know the formula. The speed of the sound wave V is equal to lambda into V. Lambda is the wavelength of the sound wave and nu is the frequency of the sound wave, right? So wavelength here 0.35 meter into frequency 2000 Hz. So if you multiply this, we get the answer 700 meter per second. So the speed of the sound wave is a 700 meter per second. That means the sound wave which has a frequency 2 kilohertz travel a distance of the 700 meter in a 1 second. So in a 1 second this sound wave travel a distance of the 700 meter. So how much time it will take to travel a distance of the 1.5 kilometer? So the time taken by the wave to travel a distance d of a 1.5 kilometer. 1.5 kilometer, that is the 1500 meter. We need to convert this distance in a meter. So 1 kilometer is equal to 1000 meter and 1.5 kilometer, that is a 1500 meter, right? So speed, the formula of the speed is a speed is equal to distance by time. From that the time t is equal to distance divided by speed. So here the distance is a 1500 meter divided by speed is a 700 meter per second. So t is equal to 1500 divided by 700, we get the answer 2.1 second. So the sound wave which takes a 2.1 second to travel a distance of a 1.5 kilometer. Understand? So next solve example, example number 12.2. Let us see the statement of the example. A person clapped his hands near a cliff and heard the echo after a 5 second, right? A person clapped his hands near a cliff and it hears the echo after a 5 second. What is the distance of the cliff from the person if the speed of the sound v is taken as a 346 meter per second, right? So here the speed of the sound we consider 346 meter per second, and the person heard the echoes after a 5 second. So here the speed of the sound is given to you, v is equal to 346 meter per second. Meter per second can also be written as a ms minus 1, and time taken for hearing the echo t is equal to 5 seconds. So speed, from the speed and time, how we can calculate the distance? By the formula of the speed. Speed is equal to distance divided by time. So that the distance traveled by the sound is equal to the speed of the sound multiplied by time. So speed of the sound is a 346 meter per second multiplied by time 5 seconds. So if you multiply this, we get a distance traveled by the sound is a 1730 meter, right? So in the 5 second, the sound has to travel the twice the distance between the cliff and the person, from the person to the cliff and from the cliff to the person, right? So here the 5 second, in this 5 second time, the distance traveled by the sound is a twice the distance between the cliff and the person. So the distance between the cliff and the person is a half of this distance, right? So the distance between the cliff and the person is a half of the 1730 meter divided by 2. We get the answer 865 meter. So now we take a last example. Example number 12.3. A ship sends out ultrasound that returns from the seabed and is detected after 3.42 seconds. A ship sends a ultrasound that returns from the seabed and detected after a 3.42 seconds. So the time taken to transmit the ultrasound and receive the ultrasound is a 3.42 second. If the speed of the ultrasound through the seawater is 1531 meter per second, what is the distance of the seabed from the ship, right? So here we know that the use of the ultrasonic sound to measure the distance of the seabed, right, in the submarine, right? In the submarine the ultrasound transmitter is there, on the other hand ultrasound receiver is there, right? So ultrasound transmitter transmit the ultrasound, right, and ultrasound receiver receives the ultrasound, and we need to measure the time taken for the transmission of the sound and the reception of the ultrasound, and from that how we can calculate the distance. So this is the example. So here the ship sends the ultrasound that returns from the seabed, right, and is detected after 3.42 seconds. So the time between the transmission and the detection of the ultrasound is given to you, t is equal to 3.42 seconds. Speed of the ultrasound through the seawater is 1531 meter per second. Speed of the ultrasound in a seawater we take a 1531 meter per second. Now distance traveled by the ultrasound in a sea, or a depth in a sea is a twice the depth of the sea. So we take a distance 2d, where d is the depth of the sea, right? So here the ultrasound transmitter transmit the sound, it reach to the end of the seabed and again transmit to the again reflected from the seabed and it reached to the receiver. So the distance traveled by the ultrasound is twice the depth of the sea, right? So we take a 2 into d, where d is the depth of the sea. So from that formula, the distance traveled by the ultrasound 2d is equal to the speed of the ultrasound multiplied by time. So here the speed of the ultrasound is given to you 1531 meter per second multiplied by time between the transmission and reception is the 3.42 second. So we get an answer 5236 meter. So actual distance traveled by the ultrasound is a 5236 meter. But the distance depth of the sea, or what is the distance of the seabed from the ship, is the half of the actual distance. So distance D is equal to 5236 meter divided by 2. We get the 2618 meter. So the distance of the seabed from the ship is a 2618 meter, or we can say that divided by 1000 we get a 2.62 kilometer. So dear student, I hope that you understand all the solve example of the textbook chapter number 12, right? Thank you very much for watching my video.